think I'm live. Excellent connection. That's always a good sign. I think chat's working. I see one chat message. Pretty sure at the end of the stream last time the chat kind of died in OBS, and so I might want to open that in just a separate browser tab, but I think I'll try it for now. It's just a little buggy. Oh, just got an email of now live, so that's useful. All right. Should get some music on for myself. I don't think with YouTube I'm going to try to restream any music, but I want to have it for myself. Just make sure my sound, yep, desktop audio is muted, so that's good. All right. What do I want to do tonight? What should I do tonight? That's the real question. There's a lot to do. Maybe I should make a little to-do list or something. Make sure that all the streaming stuff is actually working, that all the chat messages are still appearing. Let me check it on youtube.com. I guess my channel. All right, looks like everything's good. All right. So, things I want to try to get done tonight. There's a little bit of documentation. Oh. It's my wife commenting because I stole her office for the night. Anyway. So tonight I want to get some documentation written. So I guess things to get done would be write documentation. I guess what do I need to write documentation about? So what is in here, or what have people said? Oh, you didn't get the actual stream until just now. Weird. Yeah, it says on like live for 3 minutes. I know YouTube is sometimes a little fussy with that. I mean, that's a reason to do Twitch instead, but YouTube's where I currently have the most following, so it makes the most sense, but yeah. I guess I should probably also post in the Discord. This. All right, you'd think from OBS you'd be able to get a YouTube link, and either it exists and I'm just too stupid to find it, or they don't have an easy way to get just the actual link to the live stream. Get shareable link. There we go. That's posted. All right. So I want to write some documentation. I know that there are some pages on here that I have not finished yet. All right, any is definitely one of those, and how to use any. I started on it, but I have not finished it yet. General JS interop, I think, is all right. Yeah, any type, yeah. How to work with any's. Yeah, I started working on that last night, of how to use an any, but I have not really documented that or even released it yet. So if I can get that written, that'd be great. That's honestly one of the most confusing things currently in the language, but it's a really powerful feature, so you kind of want to be able to use it. And I don't need to just like reread all the documentation I've written, but there are probably some parts in here that I could refresh. And then if we have time, which I definitely should, I'd probably be live for a couple hours. I think I want to work on creating, or at least starting, the scaffolding of a Onyx tour. It depends what you want to call it, but something like this. This is the Gleam language tour, where, and this obviously was inspired by the Go language tour. I think Go calls it a tour. Oh, and then got some comments for some more things, some do blocks, closure allocations, and just how closures work. Yeah, closures are not documented, I think, at all in this. Yeah, just some of the semantics around them. But if we have time, I would like to start working on something like this, which is something that a lot of languages have, where it describes like what you're looking at in the code, and then the actual code, and then there's some sort of run button that you can click, and then it will run the code for you, and you can change this code to do whatever you want it to do, right? I could add a print line of foo, run it, and it will work. All right, am I still live? It says YouTube's not receiving any data or smooth enough to maintain streaming. I don't understand. My bitrate is fine. My upload is fine. I don't know what caused it to fluctuate so much. Stream had a weird pause. That's annoying. Why is it doing that? Okay, it's back. That's weird. Like, I'm looking at my kilobits per second, and like YouTube recommends at least like 6 megabit up, and it's fluctuating so much. And I don't understand why. Like my internet speed, which I don't want to do a speed test because that will slightly dox me, but my internet speed should be perfectly fine. So I don't know why it's dropping so many frames. Okay, so yeah, going back to the tour, this is something I want to start working on for Onyx, in the same spirit as Gleam and Go and a lot of other languages. And someone said in chat, Richard Feltman, who created the Rock programming language, which is like rocklang.org. They also have a like an interactive thing in here that you can type in, and it will do what you want to do. And there's actually just looks like on their homepage, you can just type in the stuff. Yeah, so you talked about how we set this up. So yeah, the way that I would go about setting this up wouldn't quite be that fancy, where it compiles it on the page, because I think Rock is written in Rust, and so they can more easily target WebAssembly just directly for their compiler, and so they can embed the compiler on the page. Right? I bet if I go into inspect element here and I refresh and I go to the network and I look up, I guess it'd be like fetch XHR. Yeah, so it found the REPL background, which looks like Safari you can't preview, and which is, but I think if I try to run something here, what is it? What does this run? Yeah, I would probably just ping it back to a server, is what I'm kind of thinking. So, yeah. Yeah, it depends on how server ping goes. The server ping, I mean, the way I host, yeah, how secure I can keep it. The way I host the Try Onyx site right now, this is hosted on a slightly scalable Google Cloud instance where the compiler is running in a Docker container. And so it's reasonably secure. And, you know, basically, like, the only threat here is that someone finds a way in the source code of Onyx that you can reverse a shell. But even if they get a shell, it's just into this Docker container. And so it's not the end of the world. But the fact that Onyx compiles to WebAssembly is nice because the actual running of the code happens on your computer, right? It's just the compiler that's offloaded onto a different server. And so I don't have to quite do the whole Go thing, which I don't even think I have open anymore, but Go, for their tour, they have to actually run it on a separate computer and then just stream the results back, right? I think it's the same thing with Rust's like online interactive thing, is they have to run it on a like provisioned instance of something, right? But Onyx, you can just run it in the browser, which is kind of nice. Yeah, Rock is, yeah, it's a weird mix of Rust and Zig. I think I remember that, actually. Yeah, Rock is, I guess I could go look at their code. Oh, maybe it doesn't have a, oh, here it is. Yeah, it's like, because I know it uses the Zig compile, like, there's probably a build.zig in here. Oh, maybe not. I'm not entirely sure how it's all built. Yeah. Yeah, I'm not sure how Rock's making it work, but I know for Onyx it would not be very hard to throw together a Docker container that just compiles a single file, because like this whole thing is a lot more complicated, because in here you can like create whole other files and you can like load whole other files. Oh, I don't want to save it that way. And then in here you can like define a function and, you know, log working semicolon, and then you can like just call it here. You need to actually call it like a function, right? And this isn't, that works. So like this is a lot more complicated back. It hopped again. Why? I am so confused. Our internet is supposed to be good. We pay a very non-zero amount for it, so I would hope that it can keep up with a simple 1080p stream. But with extra styling and special page routes, yeah, I could probably reutilize the try.onyx.io. And what I may end up actually doing is utilizing an API endpoint that exists on it to compile the code and return the WebAssembly, because I don't really actually need to redo that part, right? I think there's just a /compile endpoint, which I guess I can pull up the code for it. We're talking about it. So this is Playground, I believe is what it's called. Oh, I might not have that on this computer. Let me clone that really quick. Onyx Playground, I think is what it's called. Perfect. All right. sync all this stuff. Let me actually reopen this in Tmux. Okay. Yeah, it's a really simple thing. I think it's just called compile. Look for compile in quotes. Oh, it's right here. It'd be /compile, right? You can just post to /compile, and you just post code in a JSON, and it will do the compilation for you and return the WASM file. There's also this compilation v2, which is the one where you basically give it a whole directory of things, and it will recreate that directory on disk, run the compilation, and then at the end it will clean up all the extra directories. Yeah, remove directory. But I could just reuse this compile one, which you just give it the Onyx code, it compiles it, and then comes back. Okay, do it better. Set up some little thing like this, and compile API endpoint. Yeah, I could definitely use your front end library for this. Yeah, I could probably definitely do that. Yeah, because I mean, I would just reuse this. I would have to enable cores, which I think I already have. I actually forget for WebAssembly security stuff how this works. If I can serve it from a different domain name, because sometimes that's a little weird. Because the other thing that the Onyx Playground does is it's actually running your WebAssembly in a separate web worker, because I don't want you to accidentally do, right? So like you could write a while true log info, I'll just maybe call that ASDF function I made, right? I could run this and it will just spew a ton of workings. But maybe what I want to do is maybe I'm gonna do something a little bit weird here. I'm gonna use the canvas that's on the page, which is this part up here. I'm gonna use canvas sync, which basically synchronizes it to the frame rate, and so it only prints at 60 times a second, and it's not printing a ton. But as you can see, this doesn't block the main JavaScript thread, because if I was doing this the naive way, then what this would do is this would just lock up the entire browser until the program finishes. But that's, yeah. So I'm not sure if I can host it in a separate thing, or maybe I just have to do this. Oh, I think that's all you do is when you serve the thing. Oh no, that's service worker. I think it's just these. I don't remember. Oh yeah, you need a little help looking at that. I could definitely take a look at that too. So I guess things to get done. Writing documentation. I want to start the Onyx tour. And the hard part of that is what I really would be starting is actually just the baseline of it. Like making a page that looks like this, that you can type your code in. And then the really hard part is actually making the content, right? That's the part that's going to be a little annoying. And then if I have a decent start on that, I'm going to take a look at the issue in the Sword front end API, or not API, framework. Just a little something someone wants a little help with looking at how signals work in it and being able to handle them more generically. But anyway, it's a good list of things to do. So, yeah, I guess I should really just get into it. All right, so let's try to tackle this documentation. All right, what have I said so far? Any has the ability to oh, right. It continues on from how you can do types as values, because types in Onyx are all given a unique integer, and so at runtime they're integer. And so you can use that to do runtime comparisons of types, is the basic idea there. And so any is just an extension onto that, where you say any just stores a data, that's a raw pointer, and a type, which is a type expression, which is just one of these runtime integers used for every type. And so basically any is just kind of like a fat pointer. It's a pointer with a little bit of extra data that's used to store the runtime known type in addition to the actual pointer to the data. So typically you use any in a procedure by having any as the argument type. And so it kind of works like compile time polymorphism, but it's actually like runtime polymorphism. And basically the way you can think about it is that when you say like, maybe I need to make this a little bit bigger. When you say uses any 10, this is really desugaring into put 10 temporarily on the stack for this call, get a pointer to it, and then put the type of 10, which in this case would be I32, put that on the stack as well. So basically you form this little any structure on the stack and then pass a pointer to it. And then that's what gets passed as any. And so really any is just a little two-member thing. It just has the pointer to the data and a type. And so what I'm going to get into next is how you sort of look inside of an any, which is a little hard, but it's not that bad. If I were to pull open like the Onyx code, one really easy to read example of an any is this library that I just called OSAD because I'm terrible at coming up with fun names. It's the Onyx serializer and deserializer, which is just a kind of simple format for Onyx that allows you to serialize types and deserialize them in a kind of bidirectional way. And so there's certain checks here when serializing about like you can't serialize a pointer or a function because you couldn't recover that. But it's really easy to just kind of look at how this works. So this serialize takes an any and an IO writer, right? And the idea is that it's going to write the contents of this any into this writer. And then same thing in deserialize, it's going to it takes the target type and the type itself, which is not passed as an any for slightly complicated reasons. Mostly because any is more about passing something in, whereas getting it out, you generally do this pattern of passing the type and the pointer to the target. But anyway, that one takes a reader, and it's going to actually allocate and read it back. So the way this any works is you use the type information package, which I'm calling type info, but it's you might steal my Vim and Tmux configs. I feel like I have my dot file somewhere, but I'm not sure. But I am happy with my whole config. It took me a while to get used to it. NeoVim is just nvchad, and I have just a couple other extensions on top of it. And then the Tmux config, I mean, I can... where does that live on Mac? I think it's config Tmux. Nope. Tmux conf, yeah. Mostly just little helper bindings, and then using TPM, the Tmux plugin manager, and then I don't even remember what all these extensions are for. What Tmux Sensible, Navigate. The Tmux Vim Navigator is actually really interesting. I don't even know if I still have it set up properly, but the idea is that like you can use the same key binding to go from window to window in Vim and then move it seamlessly over to Tmux. So like if I open up a thing here, I could move down so if I open this, I don't think I have it set up because the binding isn't working. But the idea is that you could go from this window to this window. If I hit that same binding, I would go down to this Tmux tab and it would move seamlessly between them, is supposed to be the idea. But yeah, really it's just using that, and then I have just a little theme applied to it. But yeah. Anyway, yeah, the basic idea is just that you use this type information package, which is under runtime info, and then there's different kinds of info. So there's like an info for all the types, and then there's an info for other tags and whatnot. The tags, I believe, I have already kind of talked about in the tags directive. Okay, so this talks about how to use and access information from tags like this, and it kind of covers some of the same information that any's going to cover, but I think it'll be all right to cover it again. But the basic idea is just that every type, in addition to having a ID, also is given type information in the form of a pointer to a type info. So this is kind of like I don't want to say polymorphic structure because that sounds weird. It's actually not a polymorphic structure. Basically, this type info is like the base structure, the base class, and then all of these other type infos sort of extend it and add extra information. So the idea is that there's a pointer to this type info for every type, and so there's just an array, and every type has its index into this array. And so to get the information for it, you can just index it. But you normally don't do that yourself. You'll normally use like a helper function that's defined in this in this package. But then all these types just have other information. I'm realizing it's actually getting kind of dark. I might want to switch to either a light theme or just turn on a light in this room, but we'll see. But each type has its own like type information about different things. So, for example, a pointer is really simple. You just have a pointer type, and you just need to know what that pointer points to. So the only extra information it has is the type that it points to. Same thing with a multi-pointer. Same thing with like a slice. It's a slice of whatever, dynamic array, periodic argument, all those. And then some of the more interesting ones just have more information, right? And so like a structure probably has the most information because you have things like, well, then obviously the name of the structure, all of the members of the structure, and every member you can store, like, you can know its name, its offset from the base pointer, what type it is, if it was used, right? If you did this use tag on the member, if the member has a default value, and basically if it does, then it's a, well, how do I put this? It has to be like a compile time known default value. And if it does, then you can see that. And then if there are any tags that are associated with that type or with that member. And so you can just kind of read this and see what all the information is that's in there. And then, yeah, there's that get type info helper function that returns that pointer, and it will do a bounds check for you. So it will return null if you access out of bounds, which you never should. You should never give it a type that doesn't exist, but in case you do, is a little helper there for you. And then there's also this definition, which enables you to say type arrow info to also get the type info. And then there's all these other helper functions to do the casts to the right type, because otherwise it's just kind of annoying. So that's kind of what that looks like. So how you do this type info is you simply get the type info, you switch over the kind of type that it is, and then based on the kind of type that it is, you can do different things. So, for example, if it was a slice or a dynamic array, we can cast it to that type to get the specific info for that type. And then we have to do some kind of funny tricks here where we take the data, right? That's just that raw pointer. We cast it to this untyped array, which is a special little helper type that's used to talk about the members of an array without giving it a specific type. And so we cast it to that thing. We pull out its data and its count. We then get the size of every element using this like runtime size of. That's also in that info package. And then just per the way that this thing serializes it, it outputs the number, and then for each member, it outputs the thing. And the way that it kind of does this is it just recursively calls serialize, and it creates an any. So in addition to like any's being created implicitly when you pass something to an any, you can also explicitly create an any by just creating it like it's a structure, and then you provide the base pointer and the type. And so that's something I should also document, is how the any will be implicitly created, or you can implicitly, well, it's implicitly created, or you can explicitly do it this way. But so like, this is a really simple use case of it because it's just the most basic doing this. Odin greater than Onyx? It's a little, I don't have any bad feelings against Odin. I just think it's a little limited. But I can understand why people like it. I definitely get it. Had I not made Onyx, I probably would be using Odin. I agree. All right. Where is the book? That's not the book. Why would I be using Odin? Or why do I think Odin's a little too simple? That's the wrong. Oh, why is Onyx better than Zig and or Odin? I think it boils down to, I mean, it's personal preference, and I will start by saying that, right? Onyx is not for everybody, and I think every language has its place. Where I think Onyx shines is actually on the thing that I have open right now. Onyx takes inspiration from other programming paradigms. So at its core, it's an imperative language, and a low-level one at that. There's manual memory management, which has its trade-offs. But in addition to having these low-level things, it has higher-level constructions for functional programming. So trying to think of some of the best features to talk about with that. I mean, I guess the way this talks about it, Onyx is different than Zig and Odin, and it is used for different cases. Right? Like, Odin and Zig probably, I'm imagining they both support WebAssembly. I've never tried to do it in them, but if you're targeting WebAssembly and you know that's your end target, then Onyx will definitely, I think, be better because it's more tailored towards that. But that's obviously not a use case that everyone is going to have. But I guess just to really summarize it, I made Onyx for myself. I was bored one day, not really one day, I was bored during COVID, and I wanted to make a language. And so Onyx really didn't start by saying, I want to redefine, read what Elias says. He's got a good answer there. But like, I didn't start Onyx because I wanted to redefine how programming works and rethink the programming landscape. I made it because I wanted to have fun and create a programming language. And I like opened Onyx up to the world and shared it because I thought I made something good that other people want to use. And I still think that's true. But so it's hard for me to answer questions like what does Onyx do better than these other languages? Like, I can give you examples, but there's no specific thing that I intentionally was like, I don't like this about this language. Because I don't know, I'm a language, what's the word? connoisseur is not the right word, but I love learning programming languages, and I think every language has its strong points. Onyx is using CraneLift or MLIR. Onyx is going straight to WASM. So the Onyx compiler only outputs WASM. So that's what this is for. Now, yep. So when you are using like the WASMer build of Onyx, that's using whatever WASMer uses, which I think by default the one I link against is the CraneLift one. So when you run it with WASMer like that, it is using CraneLift. Otherwise, if you're running it with OVM, Onyx has its own runtime that is very different. That's what I call it, interpreter. So it has its own VM. It has its own WebAssembly runtime that is not as fast because it is it's an interpreted bytecode. It's not like native code, at least yet. I have slight plans and slight ambition to make it compile down to native code, but that is not a high priority. Because even in its bytecode form, it still is relatively fast. Not incredibly fast, but relatively fast. But where was I? Yeah, I don't know. I think every language just has its point or its use case. And I think I really want to just see people using Onyx and giving it a shot so I can see where it could be best used. Because it is, at its core, a general purpose programming language. You can use Onyx for many different things. I've used it for making little games with Raylib. I've made web servers, and I have a web like HTTP framework for it. It's very embeddable, so you could use it as like a scripting-like language in a game engine. It has JavaScript interop through like the same way that Go does, and so you could build simple front-end stuff or use like the WebGL package to create things like that. Like, it's got a lot of potential, but I'm struggling to keep up with demand on documentation and tutorials and other things like that. But anyway. Yeah, I know I didn't really give you a good answer there, but I just don't see it in comparing languages that way. Yeah, back to documentation. I'm gonna work on this any documentation, which I'm gonna first mention the fact that any is how you do variadic arguments of different types, because you can do variadic arguments of the same type just by doing this. You can just put a type there, or you can even do a polymorphic type, but then this still has to be all the same type. Yeah, I'm gonna turn on light. Let me go turn on the room light. It's getting really dark in here. All right. Less of a cave now. It's not a front light, so I'm gonna have a little bit of glare, but it's all right. So no, yeah, like you can do variadic arguments like this, but if you do it with any, you can do it of like heterogeneous types. So that's kind of nice. So I will give an example of this. You can do a for loop that automatically destructures any. Only because it's a dot dot. You can do a for loop over variadic arguments, and this syntax is just kind of explicitly saying that every value is type any. I don't have to explicitly say that. And maybe it's clearer if I don't say that, actually. Then I just write for value and values, because then it's like everything else. You still have to like do the logic to actually destructure these things. But I could do the same example as up above. Right, but I just use a lot of variadic any. Yeah. Yeah, no, you can loop over variadic things like this, because under the hood they're basically just slices. Yeah. Under the hood they're really just kind of syntactic sugar for a slice. It's just how the compiler like places the arguments for it. All right. This prints I32. Well, I'll make this clearer. Prints I32. Yeah, let's do it this way. I32 stir Onyx context. Find my thing. Cool. Oh yeah, no. Yep, no, that does not work. Yeah. No magic there. So I guess yeah, the part I need to get into now is how to really destructure and work with these any's. So to use the data inside of the any. This should, in theory, this should link to the packages to runtime. What is it? Runtime info HTML pound get type info. Use that procedure or the any do blocks enclosures. Yeah, yeah, that sounds good. Okay. Any do blocks, which I still can't believe I never mentioned, and closures. Okay. Okay, that looks good. Okay, to get the type information for a given type, use get type info or the info method on the type expression. And that makes that look silly because it's really long, but that's just for Vim. Okay, so concrete example here. You have to utilize the type. You can either check for concrete types runtime type information. Okay. So let's see here. Either check for concrete type explicitly. Okay. So how do I want to do this? So I have a procedure that takes an any. Yeah, any is definitely a really cool feature. It's not something that's super unique to Onyx. It was Onyx. I know it was inspired from Jai, Jonathan Blow's programming language, and I think Odin has something similar, and I think a lot of languages do. It's just kind of interesting, I guess, in all those languages that I mentioned, that it's a runtime type information thing. So it's really powerful with what it opens you up to being able to do, because it makes like printing, right? The whole reason, and I'll mention this in here, but the whole reason why you can just do curly braces for formatting is not because Onyx is using a macro like Rust, or Rust I think did it before JBlock. That could be. I don't remember when Jai added any. That could have been in Rust first, but I guess I didn't know Rust had something like any. I guess it makes sense, but I figured, yeah, Rust, they prefer to just write procedural macros and other fun stuff, right? Like, so like in Rust, the printing is done with a macro because it expands this, and I forget in Rust how you specify, like, you want to debug print this thing using the debug trait. But like in Onyx, you don't need the exclamation mark because the way that these formatted printing things work is it's all based on the runtime type information. We could take a brief look at that. I look up format. It's rarely used, but they do have an any. Interesting. I did not know that. I've never seen that in Rust code, but I guess that's kind of the thing. Yeah, debug is, yeah, the colon question mark. That's what I thought. But yeah, so like the formatting in Onyx, the way that it works is it's all based on the runtime type information. So there's this procedure called format any, which in theory is exposed and you could use, but generally you'll use it through like either conv.format or printf or one of those. But it just takes that any and it looks at, does a couple checks first about like if you're allowed to dereference a pointer to the any and it's a pointer, then do like a dereference on the pointer and then reformat it. But yeah, it effectively just boils down to doing a switch over the type, and then this just handles a bunch of the different types, and then in the default case we just get the information about the type and then handle it on a case-by-case basis, right? If it's a structure, we print it out like a structure. If it's a function or a pointer, right? We kind of do the switching there based on the kind of the type instead of the type of the type. All right. So I want to get back to writing how this works. So example I want to give. Yeah. Oh yeah. 9:30 there. Fair enough. So I guess for this procedure, I'm trying to think of a kind of useful example that utilizes, like, shows the difference between checking it like concretely versus doing it in a pattern way, or like not really a pattern, but like looking at the type information. Like print size, it's kind of silly. It's going to take the any and I'll store the size, and actually I'll use the switch expression here because I don't think that gets enough love in the documentation. Which actually, does the documentation mention? The documentation does not mention switch expressions, but I want it to, so maybe that's something else I need to write tonight. I want to double check that this. Oh, right. That's important. Oh. I have not updated the compiler on here yet, so that's fine. Let's fix the actually formatted it like that. That works. I think if I do this, this is allowed. If I do if I use optional semicolons. Yes, that does work. Okay. One second, I'll be right back. All right. Use runtime type information to introspect the given in this example, runtime type information is used to get the size of the type from the type information. To get the size of the type. So do it. Okay. So here's size. I need to turn on Vim bindings in this thing so I can comment in bulk. Okay, perfect. Okay, so this is talking about how to get that. Oh, nice. Welcome back. Working on runtime type information documentation because it plays into how any works, because really any is just the type plus the data, and so if I explain how to use the type information, that explains how you can use any a little bit better. Yeah, go for it. Offer access to AST to help facilitate them. This is a stupid little heart. I think you just said, yeah, offer. Okay. Or compilation information, generally speaking. So the Onyx AST, I don't think at the moment I plan on having that be accessible to the compiler extension. Now, that's definitely something that I would look into doing and seeing how it would look to have a compiler extension modify the AST and then give it back to Onyx. But after I write this little function, I'll give a brief little demo on how the compiler extensions currently work. And maybe that'll answer your question. So I just want to do this. So or that. Yeah, I've done some Nim before. It is a pretty cool language. I definitely agree. Yeah. Nim does macros and metaprogramming. Yeah, the metaprogramming in Nim I know is supposed to be very good. I don't think I ever got to the point where I was doing metaprogramming in Nim. But I know that, yeah, the way their macros, because they don't necessarily differentiate between, like, Onyx has these weird macros that are basically just inline functions but have different scoping rules. The way they do macros is, yeah, it takes in the AST in some way and has to return the AST. That is not how these procedural macros are going to work. At least, that is not the plan right now. But I think I'm almost done with this example. Okay. Let's print out some structures. Let's make a little foo structure here that just has like a first is a string, second is a U32, and third is a pointer to foo. Let's do that. Print struct details of foo. So I want to check this, obviously, make sure this is actually working. Oh, this one. Check it. I'm just checking them on the playground. That's just by far the easiest place to check it. Oh, I want to do an extra print with a thing there. Perfect. Okay. Yeah, exactly. You can do whatever you want with it. Yeah, let me just get this example copied in, and then yeah, I'll give a little demo of what currently exists, which I think is going to be released with 0111 because it really doesn't conflict with anything at the moment, and so no sense in not releasing it. So okay, so I think this example works pretty well. It's hard in the documentation because I could go over every single little detail of what every member of every structure is, but sometimes it's just like, if you just look at this, you can kind of look at, oh, this is a type info, I don't know, type info distinct, right? You know what a distinct type is in Onyx, at least you can read the docs for it. Yeah, 111, yeah, it's going to be pretty sweet. Yeah, you look at distinct, it's like, okay, you know what distincts are, so you understand that this base type is just the type that distinct type wraps, and then the name of that distinct type, right? So like, some of these are pretty easy and self-explanatory if you just go and look at it. So, yeah, I don't know, but I'm more happy with the way any looks right now, and it explains how any works pretty well. Okay, little demo time. Take a little break. I'm not gonna call any done, but I'll mark it as done. There's definitely gonna need to be more details in there. But compiler extensions. So I'm on this branch, which I believe is all pushed and up to date. It's the release candidates for 0111. There's a number of features in here that are breaking changes, and so I need to kind of compile them all together and then have one main push to master and release that and update all the libraries at the same time. The biggest changes have to do with like removing some weird uses of multiple returns. It just didn't really make sense given that Onyx now has these more higher level types or higher kinded types like optional and result, instead of returning multiple return values that don't express this as cleanly, switching them over to like optional and result. But anyway, that's not the compiler extension. Let's look at how that works. So I think I call it comp extension. So this is an example of how these compiler extensions will actually work from the end user's perspective. So this is me just kind of throwing things in here. It might make sense to let me actually, I think I have a better yeah, I have a better demonstration, a simpler example for sure. Okay, so this is a compiler extension. It uses this rather long name just because it's not something you're going to do very often, and so it's fine that it's a long name, makes it very obvious. You give this compiler extension either a WebAssembly file or an Onyx file that Onyx is going to run. And so this does currently have to be an Onyx written program. In theory, because it's operating over a like protocol over standard input and output, you could do like write it in Rust and then it just talks the protocol to Onyx. But for right now, it has to be written in Onyx. And so you have your extension, and then inside of these curly braces is where you define your procedural macros. Now, there's probably going to be more things that go in here related to like compiler hooks and other weirdness, but for right now, it's just the name of all the procedural macros that are part of this extension. And then the way that you invoke them is kind of like Rust, where you put the exclamation mark. The slightly curious thing about how this has to work in Onyx is the exclamation mark has to be right next to the curly brace. So that means you could write it like this, but you can't write it like this. I could probably make it work in this way. The problem is just that, like you said, this is a, what's the right word? This is a feature that is supported by the Lexer. So everything between these curly braces doesn't get parsed or touched by the Onyx compiler at all. Yeah. Yeah, so nothing in here gets touched by the compiler at all. It's all just grouped together as one token. And so unlike Rust procedural macros where you have to handle like a token stream input and a token stream output, you just have to worry about strings. And so you can use all your existing parser stuff for whatever language you're talking about that just operates on a string. So anyway, that's how you invoke one of these procedural macros. You can see there's one being invoked here at the top level, and then there's one being invoked here in the expression level. And so you can do it in either place. The way that this works, I'm worried. Let me see what version of Onyx I have installed. Let's see if this even runs. Okay, invalid compiler. Okay, 1 second. I think I need to go and build, compile, install all of this stuff. I think I downgraded to a different version, and then I never re-upgraded. Okay, so let's see. Okay, the LSP is no longer complaining. And if I run the source main, right, we'll look at what this is in just a second, but the idea is that this all compiles and this is working. So I guess let's take a look at how this works. So this extension is simply a Onyx program that speaks a protocol over input and output, like standard I/O. That protocol is a kind of low-level protocol used, well, so it's actually the Onyx serialize and deserialize I was looking at a little earlier. It's actually just that. So it's actually really easy for these to work. But the way that this works is a little helper API from the standard library where you can create an extension context and you give it a name for the extension, which is just something that the compiler will know, and if it has errors, it can refer to your extension by this name. You don't have to do this handle macro thing. I'll talk about that in just a second. But then the basic idea is you just start your extension with a message handler function. And so this message handler just takes 2 arguments, which is the extension context itself, and then the message. And basically you just have to handle all the different message types or any of the messages that you would care about. Right now, there's really only the expand macro message. That's the only like interesting one. But in the future, there could be messages about when a function is done compiling, or when a new symbol is declared, or when a new symbol is even just resolved. Like, one symbol in here is looked up and it's resolved to a concrete function, and you could know that. And so then you could build interesting things around that. But for right now, it's just expand macro. From these extensions, if you want to print something for debugging, you have to use the error printf, the eprintf function, which also just comes from core. But this actually will print a standard error, and so you can actually see it. Standard output is reserved for the actual protocol itself. So with this expand macro, all this expand macro thing has to do is respond by sending back an expansion message, and you just have to provide the same ID that was used in the actual message and the code that it expanded to. And this code is actually a result type, because if you fail to expand it, you still have to respond, but you just say that it was not supported. So the way this is currently implemented, right? Remember this one, let's look at this one. This is the double. So the idea of this one is just to return 2 times whatever you put inside of it. So the way that this works is when it gets that expand macro, we check the macro name if it's double, right? Which this is actually just a string. You could even be kind of funky here and like give these weird names. Vars and code blocks that get returned. Return string is pending. To reuse below. I think it could be really cool if you somehow could interpolate vars into a code block that get returned. not entirely sure what you mean there. I feel like there could be a way to do this, but yeah. The idea is we just check that macro, we send back this expansion, and this expansion is just literally going to be the code. We're going to take off the trailing and beginning white space on it and just return 2 times whatever the body of that expansion was. So if we look at running it, we can see that expand macro message that has the expand info, and we can see a bunch of stuff about it, right? We know that it happened at the expression level. It has ID of 2, the position where that expansion takes place, that macro name, and then just the body, which, interestingly enough, is like the raw body. It is all new lines, all spaces, all tabs. I am completely forgetting. No, do not save changes. How do you do hidden terminals? That was like T? No? P? Pick hidden term. There we go. So anyway, that's the position, the body, and everything. So that's all this thing is returning. And this could be a lot more complicated. You could, ideally what you would do is you would parse the body in some way, and then dynamically based on that, return different code, right? So you could make this body be whatever you wanted it to be, right? It could be a whole different programming language. You could, for fun, at compile time, you could put Python in here, and you could have the extension run the Python interpreter on the code, and then put the result into this this expression, right? That would be a not very hard thing to do. So anyway, that's what this thing's doing. Is it's just printing 2 times the thing. If you want to look at this a little bit more, you can run this with the tac. So the capital V flag isn't going to print much more. It just prints that the extension was loaded, and so you can see all the extensions that were used. But if you do 2 V's, capital VV, it gets a little bit more noisy because it also prints out all the stuff about all the source files, which is fine, just a little annoying. But you scroll down, skip that part, you can see that it prints out that expansion number 2, which is this ID 2, expanded to this string. And so you can see exactly what everything expanded to. Now, because this is such a common thing defining these macros, I made a little helper function. So you can say handle macro, you give it the name of the macro, and then the function that handles the macro. And what this function has to do is it takes the same extension context pointer and the expansion info, which is just the same little structure we were working with here, and it returns that result of either the code in the successful case or a failure reason in the unsuccessful case, right? And so if you failed to parse the code inside of there or whatever it happens to be, then you can return a failure. So what this one is doing is I give this just a line separated list of strings. Public. Oh no, what the heck is that? Please call this in case of emergency. Public safety alert. Well, that's the weirdest thing. Interesting. It looks like 911 is down. Interesting. Anyway, that was probably a little annoying. I'm sorry about that. I don't even think if my phone was on Do Not Disturb, I think that still would have gone off. Anyway, back to this. What this is doing is it takes this line-separated list of strings. It removes all the trailing and leading white space, and then it splits on new lines. So it just takes it line for line, strips all the white space off of that, and then it basically builds up these functions. So it puts down the line, which is just that singular word, as the function name, and then after that it puts down a colon, open parentheses, open curly braces, hello from, and then it puts down the same line. So like within this string, it's still going to print out the name of the function. And then after that, it puts a close quote, close parenthesis, semicolon, close curly, right? Which is just all to close all that off, and then a new line. And then just for the fun of it, I was testing if you could also then just export in the same thing, and you can. But if I scroll up here, you can see this is the expansion of that. So all of these functions get mapped to like a function with the same name, and then printing out the function that it came from, right? And so this is a really simple example, but you could imagine, actually parsing something real and being more interesting with it. So you'll notice that when I ran that, it's still doing the same thing. It wasn't not exporting it, even though I commented that out. And again, that's because this extension is compiled. You can change this extension to operate as a on Onyx directly. It looks like my LSP is having a little bit of an error there. Yeah, this will help you make HTML proxy. Yeah, absolutely. Because then in here you can do whatever. And whenever you want, you could just escape out to Onyx code and then just put out that raw Onyx code as is. And then, yeah, you could write something like div, and then in here you can do like real Onyx code, and then outside of these brackets it's HTML or something. Absolutely, you could do that. I'm getting a failed to initialize component. I think it's because this extension is actually in the source directory. Yeah, it's actually in source. So if I run this now, you can see that it still works, and this time it's running directly from Onyx source code. And so there's trade-offs to each of these. If you run from Onyx source code like this, it actually has to compile the extension every time. Yeah, also that. Because it can generate all the functions, you can just have one of these defined funcs for each element type, absolutely, and just have this build out that function. Super easy. And I think this is all going to be relatively stable. I think this is working how I would like it to work in the long run. Yeah, the trade-off of having the extension running as Onyx directly like this is simply that, well, this is going to be slower. That's the big trade-off. If I run this with a capital V so I could see the time, this takes about 76 milliseconds. And if I switch this back to the pre-compiled WASM version, it takes 5150 milliseconds, right? And that's just because it doesn't have to literally compile the whole extension before it can use it. It can just use it directly. So that is compiler extensions as they currently stand. There's probably going to be little details that change with them, but I think largely I'm pretty happy with how they work. And I do think they're already merged in to the main branch. If I can type. Yeah, they're already merged into compiler extensions, so they're going to make it into 0.1.11 when that releases, probably later this week. And so they're kind of fun. All right. Back to documentation, I suppose. That was compiler extensions. All right, documentation. Do blocks is the next thing I wanted to write. I'm trying to think where do blocks should go in terms of these things. I guess they're a form of control flow, kind of, arguably. Okay, so all right. do blocks. What is there to say about do blocks? I don't want to phrase this. What else is there to mention about closures? Can either be by value or by pointer. Here it's counted by pointer. So this will print 40. X, this will print 20. All right. Let's talk about some internal details of closures in Onyx. All right, let's see here. I don't trust the YouTube thing that's built into OBS. I don't know what about it, I just don't trust it. So I'm going to open it on not in OBS, but in the browser. I trust that one just a little bit more. Okay. Accommodate. All right. All right, so to do this, a built-in procedure called closure block allocate is called. This procedure is implemented by default to invoke context.closure allocate. You can change this. If you want to change how closures are allocated, you can overwrite. You can change this procedure pointer to do something different. Nice to have you back. Okay, it's a buffer from the Oh, nice to have you here too. Nice to have you here. I'm doing the boring part right now of writing some documentation. I think in 5 minutes I'll be able to end the documentation and start working on some actual fun code stuff. But for right now, documentation. Okay. Right now I'm documenting how closures work in Onyx, which is thrilling. I know. I think honestly some of these internal details are already good. Let's see. Closures are in the quick procedure definition. Okay. Let's give an example of this, and then I think I will call that done for now. This is an exciting part of the doc, how closures work, because even though closures are not great in Onyx because of how low level it is, they do exist, and so explaining how they work is always a good idea. So let's give an example of how you could define a procedure. And I'll do this rather explicitly and give it all the types. How you can define a procedure that will allocate the closure. I'm going to do this by printing like allocating bytes for a closure. Yes. Yes, Onyx has, very different semantics in that. It almost makes me wish that Onyx had a garbage collector, because if Onyx had a garbage collector, I could do more fun things like what Go does, but I personally like not having a garbage collector, and I think that you can get around it by just having better allocators and just better language support for that kind of stuff. But anyway, let's finish writing this documentation. So that's the function that's going to allocate our closure memory. Probably should actually do an allocation. And let's just allocate out of the heap, for example. And so then when I make a function f, let's say I make an x that's like 10, I make an f that maybe we'll take in a y, capture the x, and this has to be a quick procedure. And let's say that this just returns y plus x. Oh, I could mention currying. That might not be a bad thing to mention. Yeah, I'll mention that too. Okay, so here's a little function, and then let's just demonstrate that if you call f of 20, print that prints 10 or 30. Get my math right. Okay, let's test this just because I want to be sure I'm not messing anything up. Sorry for the flashbang. Okay. I need printf for testing, of course. Perfect. This is perfect. So this demonstrates that you're able to change the closure allocator into whatever you want it to do. And so here it just prints it before allocating out of the heap. Right, so then because of this closure here, that's when it has to do this allocation. So that's a good example. And I forget, I honestly forget that I made that syntax work, that you can put the closure block at the start of the argument list as well. I think I allow you to put a comma here if you want to. Yeah, I'm really forgiving with how you write this. And I guess I've always done the style that it's an argument list at the end, but I forget you can really do either way. So I guess I kind of need to pick which way to write it in the docs, because that will be the way that people tend to write it. I honestly like the slightly more C++ way of writing it like this, where you put the list there. Okay. And then let's briefly mention currying. A form of currying, function currying. Let's create a link on that. Wikipedia function currying. Yeah, I get that. All right, just do the thing where we just link to a thing. A form of function currying is possible in Onyx using chained quick procedures and passing previous arguments to each subsequent quick procedure. I'm going to type main there. So let's say main, let's just have, so we have like an add function that takes an X, it's an I32, it returns a quick procedure, captures X and takes a Y of I32, and maybe just for the fun of it, we'll take X and a Y, Z is an I32, and that returns this, which returns X plus Y plus Z. And so we could say the sum is add 1, well, okay, I can say, I don't know, maybe partial sum is add 1 and 2, and then sum 1 is at partial sum with 3, partial sum with 10. If I do like sum 2, sum 1, and sum 2. Yeah, I agree the implicit arguments would make this less verbose, and maybe that is a sensible thing to do. It is tricky with the explicitness because this, like, it gets a little tricky in the compiler as well, because currently I rely on the fact that you have to explicitly tell me that you're a closure by having these brackets, and because of that I can know closures have to be handled kind of completely differently, because the way they have to play with the scope of the parent block, it just gets tricky. And so I do rely on like the fact that this is known at parse time to do that. And so if I removed this, right, this would be the ideal syntax where you don't have to specify it. The slight problem then is I guess I could just say these are always closures and they always do a capture. The problem with that, of course, is if you don't use it, then you're doing memory allocations for nothing. So yeah, it's a tricky balance to strike, and I'm not entirely sure I've fully thought of everything. So I'm going to see if this example even works before I just kind of go for it. So here's currying, Onyx playground, flash banged again. Hey, is that right? Yeah, that is right. That is pretty cool to see, I will say. If you didn't need to have this, that'd be really cool. And then I guess just for the fun of it, how many bytes does this need? Okay, so this uses 28 bytes because it allocates 12 bytes for the first closure and then 16 bytes for the second closure. Because every closure has 8 bytes at the beginning for the size of the closure block. And then it has, this is 4 bytes, and then this is 4 plus 4, so that's 16. Where it errors without a type signature because of the failed polymorphism assertion. Yes. So that is a slight problem. And I mean, I don't honestly know the right way around that. Because if you get rid of these types, well, for one, this will say unknown token, which is weird. Maybe you have to do it in the postfix way if you're doing it like this. Oh, yeah. Okay. So that's a little weird. I thought that was a little more flexible. But error solving for polymorphic variable type y. And so, yeah, the problem here is just that this partial thing here needs to have a concrete type, but what you're returning is something that's not a concrete type. And, well, so, like, the real problem is maybe I get rid of the... It could first try that y and z are type of x. I think you said r. Yeah, you did. There's a silly little heart, and it blocks part of the message, and I don't know how to get rid of it. Yeah, it could try it that all the types stay the same. It just gets a little weird, because, yeah, the really weird part here is... if you set x to type t... Yeah, so I think, yeah, what you're saying there is, like, I could do this, and then I can explicitly say that if all of these are the same type, this will work. And yes, it will, because of how it has to do it. And you see there, it had to print, it could print, does it a little differently because I have one more function slot remaining. But anyway, yeah, the problem is just that this, oh yeah, I could read it. It's just a little silly. But yeah, the problem is here, it needs to have a concrete type, right? Which, like, this has the concrete type of this, I think is what it is. Yeah. So, like, this is an I32 to a function that's an I32 to an I32. And so, like, you currently... And maybe this is just kind of a limitation of Onyx's type system at the moment, but you can't have, like, unknown polymorphic types in here, because what if, if y could be a different type, all of a sudden here I could pass a string, and here I could pass a function itself or something weird, right? And all of a sudden, like, this no longer has a concrete type. So it's a tricky beast to do with how Onyx's type system currently works. I'm trying to think of how Haskell and stuff make that work. How they can return, I guess they can just return polymorphic functions, I think is the answer. Is it they have it's not higher kinded types, but they have the thing where you can say, like, this function has a generic type in it, but part of its type signature is that it's generic, right? Like, if you do partial application, yeah, higher rank polymorphism is really needed. Yeah, it's barely used in Haskell. That's where I'm like, I don't know if that's a thing. Default them onto T. Yeah, if they were on T, that would be more convenient. I agree. I don't know. Yeah, Scala didn't even have it for 3 years ago, or for a couple of years. Interesting. Yeah, and one argument that I could make is that if this is an important feature for you, this is something you can definitely wrap behind a compiler extension. I don't know exactly what it would look like, but, you could write something like curry, and you just have, like, X, Y, and Z, or maybe... the X, Y, and Z are all type T. You'd have to parse that, but then you could say, okay, in this body, so like foo is curry this. In this body, you can have whatever Onyx code you want, and then here you just have to handle translating the argument list into something that looks like this. And maybe that's kind of gross, but that's something that you could definitely do with compiler extensions. So, it's where once you introduce, once you introduce stuff like this, it can get kind of weird. Like, where do you draw the line between what should be a compiler extension and what should just be in the language? And so, I'm not entirely sure. I'm not entirely sure what should be and what shouldn't be. So I'll talk about it how it is right now, that you have to do it this way. But not to say that we couldn't improve it in the future. Okay. I think that wraps up everything I wanted to document. So I think I have about half an hour I can go for starting the Onyx language tour. So I am going to commit all of these changes. Talked about those. That, I added the do blocks. All right. Documentation. Yeah, we're not, trying to keep the feature set extensible, which is what the compiler extensions will be good for. But yeah, trying to pare it back a little bit with a little bit of feature creep. I definitely agree. Because Onyx already is kind of a hard language to learn, and so it would be really hard to market it on simplicity. Like, there are a lot of other languages out there that are a lot simpler, but a lot less powerful, I think. And a lot less flexible to different kinds of programming needs. So, it is a balance to strike, and I'll never hit it perfectly, but I think having compiler extensions and procedural macros will make that a lot more possible. So what I do, I did documentation for any do blocks and closures. I won't make that live right now because I don't want to SSH into my server and clone it and everything, so we'll just let that be. So, Onyx tour. Let's just kind of get started with it. I'm going to make a new default project for Onyx tour. A guided tour of the Onyx language. The Git repository will be onyxlang Onyx tour when it exists. Okay. So everything should be working. Perfect. Let's add. What do I need to add? HTTP server. Because this will be a proper website that you'll view. I'm also going to add the Onyx string templating library, OTMP. I think that's all I should really need. I think I'll just start out by making this. I don't know how dynamic it really needs to be on the front end. The most interesting component on it is the text editor, but I will more than likely wrap something that already exists. So Gleam's tour, what does Gleam use here? Code Flask. I don't even think I've heard of that one. Nope, that's don't want to put a space there. Microcode editor for awesome web pages. Oh, I did not hear about this one. So the one that I use for the playground is called Ace. And it's very capable. It's also kind of old. It was used on the old Cloud9 site, which is now part of AWS and their Lambdas. It's definitely more capable as like an IDE, which is what I was aiming for in the playground a little bit more. But for simple things like this, maybe something like Code Flask might actually be the right thing to put on the front end. I do wonder what it looks like to add a new language to it. Obviously, Gleam was able to do it, so it can't be too hard. And also it has been updated in 4 years. But I guess if it works, there's no point to fix it. Building your own theme. I don't want it my own theme. Adding other languages. So you add a language with options. Oh, you do. It's a Prism.js, which I do not keep up with all the JS stuff. Prism is a syntax highlighter. Oh, nice. Yeah, I loved Cloud9. I was so sad when AWS bought it and killed it. I used it all throughout high school because our high school gave us Chromebooks. And so they could only do stuff online. You really couldn't install anything. But using Cloud9, I could do basic front-end development stuff and kind of show off. Yeah. It's more than 10 years ago. Yeah. No, I was using it before high school. So that puts it more than 10 years ago. But yeah, Cloud9 was ahead of its time, right? There's like VS Code code spaces. Cloud9 was doing that a long time ago. Anyway, so what does Prism look like? Okay, I get they support a lot of languages, but what does it look like to make your own language in this thing? What do you do when you don't find answer of some problems? Depends on the problem. That's not a great answer. I will generally mull it over and just think about it for a very long time. Some of the features in Onyx, I sat on for 2 months trying to think about how to make it work. Like the debugger was something that I planned out for 2 or 3 months in my head and in notes before I actually started tackling doing it. And just because you get these like little bursts of, oh, I understand how I'm going to do this part now, just at the most random times. And so if you just wait for enough of those to happen, it can kind of work itself out. But yeah, honestly, you also just kind of pray that you're going to think of the solution at some point at just a random time. It's, yeah, I don't know. It's a skill you get together. Yeah, you can also just search and try to if you're trying to use somebody else's code, that's always a mess. Like how do you figure out how do you do that? And I say that as Onyx has slightly lackluster documentation, but I'm working on that. But anyway, yeah. No, there are definitely some libraries and stuff that are just very hard to use. Like this one I'm looking at right now, which looks very old. But I just want to know how to define my own language with this Prism thing, because it's used by Code Flask, which is a very simple like code editor for little things like this, right? And so this is what I want, but I want to make it be able to highlight Onyx, and to do that I need to define how to make my own language, and I don't know. Yeah, I don't know if I'll use Sword, just because I think, because how is Gleam making this work? When you say next, is it changing? Yeah, so I'm going to probably end up doing it kind of like how Gleam does it here, where everything is under like a sub route, and instead of doing like front end routing, I'm going to do just back end routing and just return the page. I'm guessing Gleam does something a little bit fancy when it changes. Let me just do all So when I click next here, what is that? I don't know enough about, where's this? So when I clicked on unqualified inputs, it did just load a whole new page and reloaded everything. Okay, so I'm not gonna feel bad if that's the way that I do it too. Tree sitter, yeah, I wish it was tree sitter because that would give me a good reason to make a tree sitter definition for Onyx. No, Code Flask uses a prism, it looks like, to do its definitions, which is going to be slightly annoying. And so, and it looks like, yeah, it's like an old JavaScript thing. Language inheritance. Okay, yeah, it just means if you put it on the same thing multiple times, it does that. Using with Node, I don't really want to do that. Supported languages, yeah, they have a ton. Custom language, custom class. Third-party tutorials. It's not really what I want. It's very easy to write your own plugin. I don't really want to write a plugin. I want to write a language. Oh. Languages. Extend. Creates a deep copy of the language with the given ID and appends tokens. Oh, okay. Interesting. So you can I could extend C, for example, and then I could change how comments and stuff work. Oh, interesting. That actually makes me wonder how Gleam does it, because they obviously had to solve some of the same issues. Gleam's got a lot of stuff going on here. Unqualified import, so there should be some XHRs. Gleam WASM. Yeah, so that's how. Interesting, yeah. Style? String builder. I guess I could try to Control F for Prism. That's the compiler. Standard lib. Oh, and this Gleam WASM, I bet this isn't actually Gleam running on WASM because I didn't think that Gleam did that. I think this is a binding for their compiler. I'm not entirely sure what you're pointing up at, but if you're pointing up at Tree Sitter, if I'm going to use Code Flask, I sadly can't use Tree Sitter. But maybe what I'll just do is use Code Flask and just say the language is C for now. It won't be perfect, but maybe we'll just see how that goes. Okay, so anyway, I want to get this kind of working. So let's install packages. And let's set up a very simple HTTP server. So I'm going to use, what am I going to use from server? I'm going to use router, I'm going to use pipeline, I'm going to use TCP, I'm going to use static. I'm also going to compile this whole thing with optional semicolons, so it just keeps things cleaner. Router, pipeline, static. I think that should handle most things. So I'm going to say S is a static. It's going to host /static from the static, the www static directory. Let's create a pipeline P and say P pipe S. Let's create a router. And I just thought of another thing I'm going to want, and that's a logger. But anyway, create a router, and we're going to collect methods, or collect routes, not methods. And then p pipe to r. And then we're going to create a logger in the v2 style. And then we're going to p pipe into L. And then we're going to create our actual server app. It's going to host our pipeline on TCP with, I don't know, 8 threads. That's probably excessive for now. 4 threads and max clients of, I said it to be some big number. And then we can app serve on like 80. And so let's just define a, I also need to include route, which is going to be the capital R route, but I like to do the lowercase version. So when you get /page, it's going to be, so there's a request type that I like to shorten to REQ, and then there's a response type that I also like to shorten. So request response, let's just respond with some, I don't know, HTML that just says working. And then I think I have to say status 200 and end. Okay, the LSP is not complaining, and it would be complaining, so that's good. Let's try to run this. That is me being on a weird intermediate version of Onyx. This is easy to fix. Just I'm in this half in between version where it's not quite 0.11 yet, and so I have to run this weird thing. Okay, frac does not exist, and take one was not defined. Still on this intermediate version. It's more just of an annoyance. Okay. Route is not defined. I bet that it is defined. It's just because of this error, which I just need to change this. I've changed this a number of times on other things. Interesting, it was not defined in HTTP server. Is the route lowercase in that? It is. Okay, serving on 8080. I forget my own library half the time. Okay, we get working. Nice. So let's set up the basics of a not that like a www tree with a templates directory that has a base page, and then a static directory that has some, probably need some JS. Probably will break out Tailwind for this too, but that's fine. Okay, so let's break out some of this. Okay. First things first, I would like to get, because this is kind of the classic style of this, it doesn't even look like these are resizable on the Gleam website. So that makes my life really easy. I can do some mobile styling where it gets small enough, but because theirs aren't resizable, and I bet Go's aren't resizable either, because Go has something similar to this, that I don't need to make mine dynamically resizable. So to follow just in the footsteps of all of these people that have this style, I guess Go's, they have hover icons, but it doesn't look like I can drag them. That might be a Safari thing, but that also might just be a thing that doesn't exist. Okay, so to do this, I'm going to want some kind of nav bar. I'm going to want Tailwind. Which is always a joy to set up. Tailwind setup. I always forget how to start this, right? Yeah, you need these things in your Tailwind, and then as part of your compilation, you point Tailwind, npx Tailwind, and then you run this on. So I'm actually going to open the tour in here, so then I can, well, one second. FG, close all that, open the tour. In this, paste the command, and this is going to be the current directory, www static index is what I'm going to actually load. Www static base is the input. And yes, install Tailwind. I thought I had Tailwind installed. Okay. So it says nothing was used, and that's perfectly fine. So let's open up our base HTML, and let's actually use some of them. So I'm going to create a little nav section that is going to have a, I don't know, BG blue. I'm going to just get this on the page and we'll worry about it later. I just forget. If I don't do web stuff for a long time, I lose it all. And I actually might open this in VS Code because I know VS Code has, oh, right, and then I also need, I'm gonna copy from a different project. Yeah, there we go. There we go, okay. So let's see if, oh, and then I also need to Onyx run, do I enter? No, I don't. Onyx run source main. All right, so I have, oh gosh, so many things set up. I have my template, but I need to actually set up my template registry, which is OTMP, create my registry, and I say my template registry. I forget all the details of how to use this thing. You create a registry and then you load a directory. I'm gonna load www. And this is a template registry, I bet. Yep. Okay. So we load all the HTML files out of the template registry, and this one is just going to respond with I need to make the helper function that I always make to handle this. I'm not going to get very far tonight because I only have maybe about 10 more minutes I can be on, but that's okay. I can get kind of far. That's not the folder that I wanted to open. Must come from the Onyx website. onyxlang.io. Source app, yeah. This is the function I wanted to copy. I have to use core misc. Okay, and then it doesn't know what reg is. That's right, this is template registry. The template is the view name. R is self. tprintf, I should just include. R is self. Okay. Now with all of that, I should be able to say res view base, and then I just have to provide a pointer to nothing. Unexpected token page title. Right here, you have to provide this in quotes. Oh, and if I cannot hit the wrong keys, well, that might be working. Let's put something in the nav bar. Nav bar. Ooh. Could be working. It could also not be working. Does not look like it's working. Template not found error. Okay. Templates, is the directory we're loading from? Loading template base. It's the view I gave it. Did I need to say, I don't know, I do end it here. Oh, I've put a silly colon here. That would have been easy to forget and fix. Okay. I also need to, cannot forget to link the style sheet of /static / index.css. I think that's what it is. Oh, it's not source. I do web development in like the shortest little spurts. Okay, that worked. Slap this with some P8. Let me just disable cache. I bet that's, yeah. Okay, P8's too much. P4 might be good for navbar. Onyx must have a cache, I forget, in the static. Okay, anyway. We have a navbar. Very cool. Let's do the rest of the view, and I might just call it there for tonight. But we have a navbar. I'm then gonna have a thing that splits the view. Oh gosh, so this would be flex row, and then this is a height 100%. Can I say height 100%, or do I have to do another weird thing? I bet I can't say height 100%. I bet I have to say Yeah, hard to focus, do the speed. Yeah, I'm rushing a little bit because I do got to get off in just a little while. Maybe 5 to 10 more minutes, but yeah, very interesting. Yeah, I do work kind of fast and I work kind of sporadically. So how it kind of is. Okay, let's get this divided thing. So we want to flex row. I think we need to position absolute, top 0, bottom 0. But you can't top 0, bottom 0. I think this actually needs to be in a div. That flex column. And this needs to flex grow. And this thing needs to be 100% on the width and 100% on the height. Or really, this thing can just be inset 0. That's what I really want to do there. Okay. So then this doesn't flex grow. This flex grows. And then this one, so long as it does... I think as long as it does flex row, it should be fine. Let's make it have a BG red 200. I swear... Okay, so it's... Okay, so inset 0, I think kind of works, but the min height... How do you do tailwind height 100 VH? LVH, I think is what I... Or 1 VH? Oh, screen. Min H screen? Is that a thing that you can say? Yeah. Cool. Min H screen. I think that should work. And so then in here, I don't want to do red. Instead, I want to say it's a flex row. And I have two things that are both flex grow. So I think that just sets the flex basis on them. And they are going to... I'm going to put a gap here, maybe. And so I actually will need to say like BG gray 700 or something. This one's going to be BG green 200, and this one will be BG red 200. Hey, that actually just worked. You know, little things, when those things just work. Right, this gap could be like 1. That looks pretty good. And then on the right client, I actually want to also be able to do flex column. This is where things get a little bit more interesting because I want to have 2 divs. The top one is going to be for the code. The bottom one's going to be for like the way that Go does it, where it's going to have the actual what code is run. So how do you do tailwind flex percentages? Flex basis? Is that what it's called? Oh, you can just do basis that. Okay. Easy. Basis, oh, 4 2/3. Basis 1/3. And let's say this one is a BG. Let's do like a really dark blue, and then a really just like black. Which I guess is like gray 900. I don't know if that's how you actually do that, but yeah. Okay. And I think there all you need to do is add a little bit of gap as well. I don't know why the Onyx server caches that. Okay. That looks good. And then so long as the background of this is also... Do they spell it with an A? I think they spell gray with an A. There we go. Okay. I'll use the actual Onyx colors when it comes to it, but I think this sketch out is pretty good. I think that nav bar, seeing it, it's a little big. Maybe we padding 3 that. Yeah, that's better. Okay, now I can drop my stuff in my divs, and that's that's what I was hoping for. So, got the annoying hard stuff done first of setting up the project and getting something that looks like what I want to have. So I got the code. I'm not going to check in the index file. I guess I could. I shouldn't. I'll check in all these files though. The git ignore, Onyx package, tailwind, initial project setup. Okay, so I've technically started the Onyx tour, but not the interesting part. Not the part that actually compiles the code, and not the part especially that actually is the tour that has the actual content. But that will come later. I may be streaming again this weekend. I'm not entirely sure of my plans yet. I know I will not be available tomorrow night, and maybe Friday will be, and maybe Friday even during the day I will be, but not tomorrow night for sure. So anyway, thanks everyone who tuned in and who's still watching. I will keep these on my YouTube for anyone to watch later. I think this one is a little bit more contentful compared to the one from last night, but that's all right. Have a lot of open tabs. Did a lot of stuff tonight. So we're going to continue working on the Onyx tour on stream. I'll probably only work on that on stream so long as I keep finding time to stream, because then that's a good documentation and good examples of working on stuff. So anyway, thanks everyone for tuning in. I will hopefully see you guys the next time I'm streaming, maybe this weekend.